Hello everyone, welcome to this video, and in this video we will be learning everything about sets in C++. So let's get started. What are sets? You can think of sets as a data structure which contains only unique elements. So you have to remember this thing. Whenever you are dealing with unique elements, that means all the elements are different, all the elements are distinct, you can think of sets. So sets are like basically a data structure which cannot have duplicate elements. So when I write, let's say a set has these elements, you can see that one is repeated twice. So this cannot happen in a set. So for example, let's say you have a set named as set1 and it already had these elements 1, 2 and 3. Okay. Now you go ahead and say that, okay, I want to, let's say, insert the element 3 again in set1. Sure. I mean, you can go ahead and do that. But at the end, because 3 is getting duplicated, it will only appear once in the set. So the set 1 finally, after inserting 3 as well, it will remain the same. So this is the power of sets. So whenever you have to deal with unique elements, whenever you have to deal with distinct elements, always think about sets. So like you might be thinking like, why cannot we do this using vectors, right? So let's say you have a vector of this 1, 2, 3, and then you go ahead and want to insert 3. Okay. Now you need to know, right? Like, is the element 3 present or not? Then you have to iterate over each element, and then if you don't find 3, you will go ahead and push back, or else you won't. So this is not very efficient. So sets are dependent or based out of how they're implemented, something called as red black tree. So we won't go into the details of how a set is implemented because this is a topic for another video. But whenever someone asks you, do you know how a set in C++ is implemented? You can talk about that, yes, it is based on a red-black tree. So like a red-black tree is basically a self-balancing binary sorts tree. It is always balanced and all the elements are always kept in sorted order. So you cannot have a set which will have elements in unsorted order. It can't have like 4, 2, 3. It will only have like these elements as 2, 3, 4. Because this is what makes inserting an element or erasing an element very easy from a set. The fact that it is sorted. Okay. So always remember this. Now let's go ahead and see the implementation part of it. So as I told you that set contains unique elements and it always contains it in a sorted order. You can include this header file set, and I mean I'm just showing this because this is what the specific header file will include set, and like anyways this will include all the important libraries that you will ever use in coding. Okay, and this is a function that I have implemented just to print the set every time, so I don't have to write this for loop again and again, just to show you guys. Okay, let's come to the first part, the initialization. So you can just mention that this set will be data structure of integers. That's how you initialize it, and let's call it S1. So set int S1. You can also initialize a set like this. So set, let's say we have elements 1, 2, 3, 4, and then let's say insert 1 again. Now let's try to print the set. Okay. So as I told you that this set will only have like unique elements. So you see here, it only has 1, 2, 3, 4. So it's not containing 1 twice here. So that's what I wanted you to show. And one more important thing here is that you cannot access the elements of the sets like you did in a vector. So you cannot go ahead and say, okay, I want to print the first element, let's say the S2 of 0. If you try to do this, you will see that there will be an error that comes. So this is not defined for a set. So this is something that we need to take care about. So there is a command called as auto. So there is an iterator that you will define, and then you iterate over for auto IT. In my particular set S2, you will go ahead and print IT. Okay. So this is how you can iterate over the elements of a set. You have to remember that you cannot directly access the elements of a set. So why I got printed 2 times? Because I called this function print set on S2 where I'm doing the same thing, and here I again printed these elements. Now moving on to the next part. Let's say you want to insert one more element to our set. How you can do that, right? So there's a function called .insert, and let's say we want to insert 5. After 5, we'll go and try to print this set again. You will see that 1, 2, 3, 4, and 5 are there now. Okay, just for clarity, you can also insert a new line after all of these print statements happen, because then you might be confused, right? Because everything is happening in one single line here. So yeah, so you print the elements of the set, then again we print it using this auto command, and after inserting 5, you see that 5 is inserted. Now let's say you try to insert 2. So do you think that 2 will again be inserted here? No, right? Because that's the definition of set, and you can see it here. It is always 1, 2, 3, 4, 5. Even after inserting 2, it's not contained again. Okay, now moving to the next part. How to find the size. So this is like pretty simple. In all the STL data structures, you can implement this dot size, right? Because we have 5 unique elements, we print 5 here. This is the size of our particular set. Now, there is also a very good command to check if the set is empty or not. So you can just write if s2.empty. So because we have elements, we have 5 unique elements, this will be printing 0. And 0 means false in coding and 1 means true. Okay. So this is like a pretty simple implementation, right? You could have also checked if s2.size is equal to 0, it means that it is empty. But generally, it is a very good practice to use this, which is s2.empty. And by the way, like the time complexity of each of these operations is log of n. We will talk more deeply and we will get more intuition of why these operations are log n. But for now, you need to remember that everything is happening in log of n times. So this is a pretty efficient data structure to insert and find elements. Now moving to the next part, right? So let's say you want to find if element 2 is present in the set or not. So what you will do is that if s2 dot find, what is the element that you are trying to find? 2 is not equal to s2 dot end. So this is how you can find a particular element in the set. Then you can just write, yes, I found it. So let's try to execute this and see if this works or not. Yeah, so you printed it, right? So the element 2 was there in the set, and that's why it went inside this if and printed this statement. So the thing here is that whenever you are trying to find a particular element in a set, if the element is not present in the set, what this find operator will return will be s2 dot end. So this is basically an iterator to the kind of a ending position to that set. So for example, our set contains 1, 2, 3, 4, 5. This iterator pointing to 1 will be s2 dot begin. And this place after 5 is s2 dot end. So whenever you don't find an element in a set, this iterator will be returned, which is s2 dot end. So let's try to clarify this concept, okay? So we will see 7 is not here in the set, right? So what we will do is, if s2.find is equal to s2.end, then we can say that no, I could not find, right? So we expect this to print no, I couldn't find this. And that's what you see on the screen. Because 7 was not there in the set, it returned h2.end that I showed. So any element you could have searched here. It can be like -1, -2, infinity, 500, 69, anything. It will return h2.end, and that's how you know that the element is not there in the set. And this operation also takes order of log n. And by the way, n is the size of the set that we are talking about. Okay. Now, let's say you want to erase an element. So we know how to insert. Now we will talk about how to erase an element. You can just simply write s2.erase. Let's say I want to erase 3. And then I will go ahead and print my set again. So now we expect that 3 is erased, right? So now you can see that we only have 1, 2, 4, and 5. So this is like all the important operations that you need to know for sets. And in the future, we will see how to implement a lot of problems using the syntax that we learned today. So see you in the next video. Keep smiling and be happy.